Recording. It is 6 p.m. on April 19th, 2018. This is the normally scheduled class of ITSE 2309 meeting at Preston Ridge campus. Let's see, a couple of announcements. The first announcement is to read your announcements on Canvas because the class meeting time for the next class, the ITSE 2347, which is the advanced database programming, has changed to, I forget what it was an afternoon class 2 days a week. It has changed to an evening class on Wednesday evening only. And it meets in H133 at Preston Ridge. So if you're interested in taking that class, you should sign up for it because it will not be offered next semester. I mean, it will not be offered in the spring of 2019, is what I mean to say. What else? I've been asked to bring the test 2. I've been asked to make test 2 become active tonight. I'll put out an announcement on that. It will become active about 7:45 or 8 o'clock, something like that. I will make it available. And it will be available until 11:59 on Monday evening. I always say 11:59 because that's some question on which day is 12 midnight. If you say 12 midnight, what day is it a part of? If I say 12 midnight, am I talking about the one between Sunday and Monday or Monday and Tuesday? But if I say 11:59, there's no question, PM. Only one of those. Cutting these out, okay. Now, we're going to be talking today about database design. So this particular class is going to be more theoretical than the others have been, where up until now, this class has been pretty much you write code. What I'm going to talk about now is more the semantics or the meaning of database, designing database down under the covers as more of an art form than it is specifically how you do it. Because given any specification, there's probably about, as many different ways to do it as there are people who would do it. So we're going to talk about that, and we're going to look at our database, our accounts payable database, and see if there aren't a few things that we might do differently in it. There are quite a few things I would do differently, but I kept the author's basic schema. Now, we've been discussing in this about related tables, and tables are related through their foreign key, primary key relationship. Now, do you have to relate through a foreign key, primary key? No. No, you don't have to have a foreign key. A foreign key can exist only in your head. When you set up a foreign key constraint, what you're setting up, you're saying that I'm going to access this, I'm going to join tables on this relationship. Therefore, I want it to be, the database will enforce the integrity of that relationship, meaning that the database will not let you get a child with an invalid parent in there, unless you specifically do something to disable the constraint on the database to put it in, which is what I did to a few of them. Disable the constraint, put in invalid data, put the constraint back. That will happen. People will not do the constraint, and until later they'll set it up, and then they'll start throwing data at it. Then they'll add the constraint afterwards, and you have invalid data in there. So you have to be able to find it. Because it does degrade database integrity. I put a couple in there just so you'd have something to find. Okay. Now, we talked about the one-to-many relationship. Okay, I have a one-to-many relationship. How do you do that? I guarantee you that is going to be a test question on the final. How do you create a one, that got your attention, huh? How do you create a one-to-many relationship? We've been doing it all semester. Now think about how you did that. For example, on the very first test, very first assignment was creating two tables that had a one-to-many relationship. I believe, what was it? Doctors and patients or something like that. You can do pets and owners, anything. There's lots of things I could do. How did you do that? I have two tables. I have a table, let's go back to patients and doctors. I have a table called patients. Patients have a primary key. I have a table called doctors. Doctors have a primary key. Let's call it DID and PID, okay? And other stuff, doctor's name, address, phone number, all of that good stuff. How do you create the foreign key? Well, yeah, yes, it's a constraint, and that's the syntax of the SQL that you do it in. But in general, whether you're doing it through SQL or through a graphical user interface, it's always done the same way. What happens? The primary key of which side? That's important. The primary key of the one side, so it's a one-to-many relationship. The primary key of the one side is copied over into the many side. In my opinion, it should keep the same name, if you can. Sometimes you can't. It must be the same type. So if it's a varchar on one side, it's got to be varchar on the other. If they're not the same size, you're either going to run into the end of it or you're wasting space. If the one side is bigger than the many side, you're going to run into a problem because you can't put it in the many side. If the many side is bigger, you're just wasting space. It's just a waste. You can never use it. So keep them the same type. If one of them were varchar and the other were char, it would work, but not well. But you can't have one side be a number and one side be a currency or something like that. It just doesn't make any sense. Okay, then you set up the constraint. References the primary key. Remember, the primary key, there's two things that when I say it's a primary key, I'm saying two things about it. Unique and cannot be. You're saying it, I think, Kathy. Are you saying null? Not null. You are correct. Mm-hmm. I knew that's what I was hearing. Okay, so unique, not null. Have to have one and cannot be null. When you have a foreign key, all they're saying about the foreign key is that if you have one, then it must be in the parent table. That's all. You're not saying that you have to have one. Now, if you want it not to be null, that's another constraint. Okay. Now, we've talked about, so pay particular attention to that one-to-many relationship. That's a big thing. If I constrain the foreign key, the child, to not be null, then I'm saying no orphans. Sometimes you have to allow orphans. Sometimes you don't want them. That depends on what you're trying to do. Okay. Maybe you do, maybe you don't. Most of the time on a foreign key, I say none. Another constraint that you can have is, we haven't done it yet because we don't do it a whole lot, is a unique constraint. Okay. Or what would happen if I made the primary key of the child table a foreign key into another table? It's unique. So I've got a primary key So I've got a patient, I've got a parent, has a PID, a child, CID, let's say. And the CID is the primary key of the child's table. The CID is also a foreign key into the parent table. What do I have? What? No. There might be a good reason to do this, and that's not going to be my next question. When would you do this? First of all, let's think about what we have. Primary key of the parent table must have the primary key, must be unique. Primary key of the child table must have one, must be unique, no orphans. The child table references the parent table. So the parent has to exist first, and then I can put the child in. How many children can a parent have? What? The foreign key referencing the parent table is the primary key of the child's table. How many children can a parent have? No duplicates. The primary key is the foreign key. So parent ID 23, the child ID is also 23, references the parent table. I can't have another 23 in the child table. So I have a 1-to-1 relationship. When might you do this? Oh, let's say that we are in someplace, Dallas maybe, or Washington, D.C., where very few people have cars. If you live in New York, you don't own it. It's too expensive to have a car. So typically you take public transportation, okay? But some people in your database might have a car, one or two. Of them, I want to keep the information, the vehicle information on that car. It would be, and they're only allowed to have one car, by the way. They can't have many. Therefore, since everybody has, I'm only going to have one, but it's most of the time they're just going to be null. It's good to set it up that way, where they only have one of them. I'm trying to think of a better example, because somebody could have 2 or 3 cars. Trying to think of something you can only have one of, but you probably don't have any. But if you do have one, there's only one. Maybe it's a driver's license or something. Nobody here bothers having a driver's license. So if they have one, we keep that information. Most people don't. Therefore, by setting up that foreign key, I'm saving a lot of database space that would just ordinarily be null. Okay, let's look at this setup. I'm on the screen now, and I will provide you with a copy of this. Notice let's see, I'm SW Smith DB. That would be your own database. I'm going to create a couple that we've had patients and we've had doctors, right? I'm going to create 2 tables here and a relationship, and I'm going to call them patients and medications. So one patient can take how many different medications? Any number, 0 or more. A medication may be taken by how many patients? Any number, 0 or more. Therefore, between patients and medications, I have a many-to-many relationship. Okay, this is how a many-to-many relationship happens. There's nothing really new here. It happens with foreign keys. This is called I will call, let's go ahead and look at these. I just create a couple of very simple tables. All it's got is primary key and a name. And then I create this table that I call a bridge table. It goes by different names. But bridge table, a join table, excuse me a minute. The primary key of the patients and the primary key of the medications, primary key of the patients, and the primary key of the medications both come over into the bridge table. See how they're both there. The primary key of the patient's table becomes a foreign key. The part of it references the patient's table. The other part of it references the medications table. I have some options with respect to what is the primary key. None of them are perfect. I can make the primary key be both of them together. The downside of that is I have a two-field primary key, as you can see I do here. So I have a two-field primary key. Okay, I do. We're going to see over in the accounts payable database that we have a couple of those. The other thing I could do is I could give it a timestamp, or I could give it an identity, number it, and let that be the primary key. In that, probably a date would be better, because in this case, well, what is this? What is this entity, this thing? I'm calling it PAT meds, patient medications. That's really a prescription, isn't it? So there would really be a whole lot more information recorded about that. And one of the things that would be recorded would be a date. So a date might be a good place for, this might be a good place for a timestamp. Questions? Thus, I can insert data. Okay, I've inserted a few patients. I've inserted a few medications. I guess if Band-Aids count. I didn't know how to spell many medications besides aspirin, so I just made up a few. And then Joe, patient ID 1, gets medication ID 300. Patient ID 4, I believe is Betty, also gets medication ID 300. Thus, I can answer questions, show me all of the medications prescribed to patient ID 23. Show me all of the patients who are taking medication ID 600, assuming I had that. So by joining, I would have a three-way table join. I would join the patients to the patient meds to the medications. And now I have all of the information in a many-to-many relationship. Inner join, outer join works just like it always has. Remember, if a medication is not prescribed, it won't show up in an inner join. But that's most of the time I'm asking about a particular patient. If I put something in, if I put a field in the patient's table, that field would apply to all patients. So it might be something to the effect of a note, drug allergies. This patient is allergic to penicillin. That would go in the patient's table. Once you specify the patient, you see that allergy. If I put something in the medications table, that would apply to all medications of this one. For example, medication 300 might be, do not drink alcohol with this medication. It applies to anybody who gets that prescription will get that constraint on it. It's not a constraint like database, but it's a note. It will apply to any prescription of medication 300, whatever that was. So a placebo. That's a medication that does nothing. Do you know what a placebo is? It's a pill that they give you when they think that you just want them to give you a pill. Here, it doesn't do anything. And let's see, if I put it in the patient medication, it will apply to the specific prescription. In other words, take this preparation, take 1 pill 3 times a day with food or something. It's your specific instructions. Let's look at this in a diagram. Didn't do much, did it? Okay, here it is diagrammed. Database diagrams are handy. Now notice the notice that I have the patient meds, and notice that I have 2 one-to-many relationships leaving it. That's how you recognize a many-to-many relationship. You have a table, and it has 2. It is the one side, no, excuse me, it is the many side of 2 one-to-many relationships. So I have a 1 to many coming from the patients, and then I have a 1 to many coming from the medications. So it's many coming in on both sides. Whenever you see this, you have a many-to-many relationship. Sometimes you'll have them and not even realize it, but it exists. Okay. Questions? Which table would I have to drop first if I were dropping these tables? Which one? Yes, the patient medications, yes, because I always drop the child first. After that, it doesn't matter. The patients is not directly related to the medications table. The only way I can get from patients to medications is by going through the bridge table. Am I making any sense at all? Okay, let's look at a little bit more complicated. This is the database diagram of our AP database. Can you see a many-to-many relationship in there? What tables are related in many-to-many? There's 2 tables that have a many-to-many relationship between them. What are those 2 tables, and what is the bridge table? The bridge table is invoice line items because I have it's the many side of this relationship, the many side of this relationship. There is another one, by the way. Invoices is also a bridge table because it's related here and here. Okay. Let's see, I suspect that it's related by, I think the terms ID, invoice number, invoice date, terms ID references here. So the vendor, yeah, I don't think the default terms ID is involved in that. I don't think that's either a foreign key or a primary key. That's just there. The vendor ID references the so between the vendors and the terms is a many-to-many relationship. One vendor can have many terms. One term may apply to multiple vendors, and they're related through the invoices table. Also, the invoices and the general ledger accounts, GL accounts, are related through invoice line items. We're going to talk more about invoice line items in a moment. Notice that I have a couple of tables over here that just aren't unrelated. It's got a primary key of invoice ID. So if we were talking about the invoice archive, probably that invoice ID is related. Now, I did not set up a primary key on that because in the next class we're going to work some with it where it doesn't have a foreign key. I would have a foreign key. but there may be reasons that they don't want a foreign key. I haven't really chased it down to see why not. Questions? Okay, I just wanted to mention that about the many-to-many relationship. So basically, database is built out of one-to-one relationships. I have a one-to-one relationship when everything's in the same table. Or I have a table with a foreign key, primary key relationship, primary key, foreign key relationship, and the foreign key has to be unique. Once I say that foreign key is unique, now I have a one-to-one relationship, and I do this when I have what's called a sparse relationship. I don't have many of them. Maybe I can only have one. So it's a one-to-one, but I don't want to put them in the same table because most of those children, most of that relationship is just going to be empty. So I get a big win by setting it up as a foreign key. Sometimes you will set up foreign keys. Let's see, you only live in one state. So I would probably set up your state as a foreign key, and the state, I would have the state name, the state abbreviation, referencing the state abbreviations table, and then the state name in there. And now I could print out the state name. So if you lived in Pennsylvania, I'm only going to put in my database PA. But when I show it to you, I'm going to spell out Pennsylvania, and I'll do that with a foreign key, primary key. It's real easy to do, saves me a little bit of database space, not much. Okay, I'm going to move on to our module, because the module is really kind of about something else, but I think that's important. Well, it looks like I've closed all of my, let's see, Mozilla. Ms. Wallace, are you able to use Chrome on, you use Chrome?
Yes, sir.
Do you use Chrome on Canvas here?
Yeah.
I've had some issues with it not working. Our effective day, our module today is, what's that, module 12. And we are going to go on through, we have 3 more modules and 3 more class meetings. So we're going to take 1 module per class meeting. Wherever we are. Like I say, we have finished up pretty much SQL proper. We finished up the coding that we're going to do. Now we're ready to go into the advanced side of the coding. So we finished up from here. What we do is we go look at SQL as it relates to another programming language as it's run inside of that. And what we're going to do in the next class is, for those of you who are interested in taking it, we're going to set up a Access as a front end, and our Access forms will run on one machine. We're going to pretend, and SQL Server is running in the back end on a machine someplace else. Now, in reality, they'll both be on the same machine, but we'll have a client server set up both on the same machine. And Access forms work very well for that. Actually, Access forms are fairly advanced, difficult programming environment, as we're going to find out. It's Visual Basic. Okay, let's talk about Module 12. Find the exercises to be fairly easy, I believe. Introduction. Gives our objectives, reading assignment, page 305 to 330. Here are the slides. Sometimes I actually use those slides, but not often. Okay. We're going to talk about normal databases. If I can have your attention, please. Normalizing a database. Normalizing a database is really an art form. There is nobody's ever been able to come up with a computer program that can do it. A database, normalizing a database involves you knowing something about the database. So it doesn't make any sense to start talking about this from the beginning. Okay. From the beginning, I'm talking about, okay, we're going to get these data out of it. And now we have been working with this database for a while. Now we know something about how it's designed. So now we can ask if it's in normal form. Okay, there are 3 normal forms. Actually, there's a whole bunch of them. I think there's 7 or 8 normal forms. We're only going to be interested in 3 of them. Okay. First, second, and third normal form. A database is in first normal form, and I believe I gave you this on the first day. A database is in first normal form when, by design, there can be no duplicate rows. Well, that implies the existence of a primary key. So when you set up a primary key, you have hit the first piece that it has to be in first normal form. Okay. A database is in first normal form when, by design and by deliberate intent, you do not access those data by any other way than the content of the row. Now, I will show you something that you can do, and we're going to do it in the next semester. You have a row ID. Now, those data have to be out there on the disk in some order. The row ID takes you to the specific disk page where that is. It is the fastest way to get there. We do not, if you do that, you are violating first normal form. But sometimes we do it anyway. Okay, it can be done. So we do have, there is a variable called row ID. We can talk about it. You have a way to get it. So you can talk about the 27th row in the database. The problem with it is, as you insert and delete from that, the row ID could change. Okay. So if you're going to use it, you pretty much have to be in the database and be able to lock it and say, nobody can touch this while I'm doing this. So it might be some kind of a supervisory task that you're doing where you need to get into it quickly and get through it. Okay. But, okay, data are accessed by content only. We never talk about row 5, field number 7, for example, even though we can. It's possible, but we don't do it. Okay. Last but not least, a field has exactly 1 value. Now, what does this mean? Is it possible to put 2 or 3 different phone numbers into a field? My phone numbers are 1, 2, 3, 4, 5, 6, 7, comma, 2, 3, 4, 5, 6, 7, 8, comma, 3, 4, 5, 6, 7, 8, 9. Would that be legal in a varchar field? Sure. Well, yeah, it wouldn't be very good. I mean, consider that I ask you to go in and find something about the area code. Remember when I would ask a question about the area code? Are we not treating the phone number as if it were several different values? So you got an area code, you've got a prefix, and then you got the phone number. So isn't it really 3 separate fields? And the answer to that question is yes, it is. And yes, we treated it as that. So when we went in and we did that like thing, and we broke it out and we searched for just the area code, we were violating the first normal form. When we say it's in first normal form, we say we're not going to do it that way. If you want to be in first normal form and you need the area code, he needs to get split out into his own field. Area code, prefix, last 4 digits. So if you have a social security number and you ever intend to access that social security number by first triplet, center tuple, and then the last 4, they need to be in 3 different fields to be in first normal form. That's what it means by a field has only one value. Can you go in there, and when you have to, can you go in there and find somebody that the second letter of their last name is an A? Sure, I don't know who I want, but I know that the second letter of their last name is A. Find all those people. Could you find it? Yeah. Kind of tedious, but you could program that pretty fast, pretty quickly. That would be a violation of first normal form. Oh, well, I mean, there's no policeman that's going to come along and get you if you violate it. Okay, you're in first normal form when your data, by intention, conforms to those 3 rules. It has a primary key. In other words, there are no duplicates. It is accessed by data are accessed by the content of the row only. And finally, the fields contain exactly one value. Okay, I should not have a first name, comma, space, last name, or last name, comma, space, first name, whatever it was. That would be a violation of first normal form because I got the first name and the last name in the same field, and I'm probably going to want them in separate fields. I'll break those out right away. Tables are related through the foreign key. I talk a little bit about that. Here we go, dogs. Here we talk about the many-to-many relationship. And so I'm introducing that here. It's the same thing. It's one I do a lot. I have dogs and tricks in the bridge table. I name the table dog tricks. One dog can do many tricks. One trick can be done by many dogs. It's exactly like the example. Composite primary key. Neither key may be null, and together they have to be unique. Questions? Have I lost everybody yet? Have I confused everybody yet? Okay, go on. Here is a good video on database normalization. I'm not big on playing you videos. I don't want to make you come up here and then I sit here and play you a video. Bill Nye the Science Guy. Did you see that one on, let's see, there was a piece on him last night on PBS. My science teacher would play it. Now, I never minded it because he was a lot better teacher than he was. Identify the data elements. So the 6 basic steps for designing a data structure. Identify, get it as small as possible. Well, I'm just going to... I'm going to come back to this one. Basically, we want to get anything, it says subdivided into its smallest useful component. That means that it depends on what you're doing with the data. An address, consider an address. Should an address be in one field, or should I have a field for the number, a field for the street, a field for the city, for the state? It depends on your business. It depends on what you're doing with it. Is just the address, are you looking at the address as one item, or are you looking at it as composed of several? It depends on what, if you're thinking of a car. In your business, if you're in the human resources business, an employee's car is just a car. It's just a primary key, probably the license plate number and state, I guess. But if you are in the car business, if you're running a car dealership, you're going to have a lot finer granularity there. It just depends. What is a useful piece? In this case, the example here is the first name and the last name. It matters. But if I were a veterinarian and I ask, what is the pet's name? And the pet's name is Feed Me Again Jones, I probably am just going to put that all together because I don't really care about the pet's last name. Besides, they can't spell anyway. But definitely first name, definitely last name. Address divided into its components. Maybe. Am I ever going to access it that way? Will I ever ask for my customers that live in a city? Probably. Identify the tables and assign the columns. Okay. A database is in first normal form when it has a key, essentially a key, and it conforms to the other two, access by content only and no multi-valued fields. But those involve how you're going to treat the data. So if you're constantly going in there and trying to split up a field, you need to break those into two separate fields. Okay. Next time you maintain the database, you'll take care of that. A database is in second normal form. Second normal form. When everything what the row depends on the whole key. So the key might be, well, there is a key. Let's go quickly and look at this one. Notice the invoice line items. It has a compound key. The row, the unique row must depend on the entire key. Okay, so just half of that, just the invoice ID is not enough. I have to have the invoice ID and the invoice sequence. Let's go look at some of the data. Go to tables, invoice line items. I'm going to say edit top 200. Notice that it's pretty much the invoice ID, but for example, I have duplicate invoice IDs in there. So the a unique row depends on the invoice ID and the invoice sequence number. Do you see any other way I could have done that? See, you're going to set up a database and nobody's going to tell you if it's right or wrong. And you say, I look at some databases, this one, for example, and I say, why on earth did he do that? I don't know, but there's a way around that that just jumps out at me. What else could I have done? Notice all of the duplicates that I have in the invoice sequence number. What are most of them? As you scroll down through it, it looks just about like that and all the way down. What are they? Ones. I just have a whole bunch of ones and a few things that aren't one. In fact, I don't think I have, and we've done a query on this. I think, look there, there's a 2. I think the rest of them are all ones. So I only have 1, 2, 3, 4. I only have 6 in there. Well, actually, I have 4. I have 4 rows that aren't 1. What's special? Why do I want to see 1111111? I don't. What else could I do? What else could I have done? Well, yeah, but the problem I would have then is that the invoice ID isn't unique. There are 6 of them there that have at least one duplicate, which pretty much kills the idea of that being the primary key, which was what the author was trying to get around. Okay, that's out. I have to have the invoice ID. I have to have a primary key. Oh, I could use the invoice sequence number. Just start with 1 and increment it every time. Can I still get the same information? Sure. Just count the, for example, I can know how many sequences invoice ID 12 has. Go count them. SQL does that very quickly. I can print them out for you. I can show you everything. I can show you all 4 of these where the invoice ID is equal to 12 and these invoice sequence numbers would be different. I don't care if they're in order or not. I don't care if one of them's a 12 and later I get a 23 and later I get a 46. Doesn't hurt me at all. They don't have to be all together. SQL will take care of that. Then what have I got? Now I have one single primary key. My point being that this is not in second normal form, because it doesn't depend on the whole. Or let's put it this way, I could improve this table, improve the performance of it. Anytime I can get rid of a compound foreign key, I'll do it. Usually. Depends on how hard it is. This wouldn't be hard at all. And all I would do would be to change this to be an identity. And now the semantics have changed, right? So it's not just 1, 1, 1. So they don't necessarily come in 1, 2, 3. But that's okay. They would be in order. So the first row would be less than the second row. And you could sort it out with the SQL. I don't need them all to come together like this. It's not important. Okay. So first normal form, you have a key. Second normal form, the individual record depends on the entire key. If you have a compound key, then you can't have any extra pieces in there that aren't being used. In this case, I've got pieces that aren't being used. So the key and the whole key. The other thing is that the third normal form, you are in third normal form when an individual row depends on when I can resolve an individual row only by the key. Now, this doesn't mean that it's not accidentally unique in other fields, but I only use the key to reference that a unique row of that table. Okay. So we have a saying about that. Third normal form. First normal form, the key. Second normal form, the whole key. Third normal form, nothing but the key. Now there it goes. The key, the whole key, and nothing but the key. And then we append to that. So help me Codd, C-O-D-D. Boyce Codd was an Australian person who proposed the normal forms. So that's your little mnemonic. The key, the whole key, and nothing but the key. So help me Codd, and that gives you the third normal form. So mostly these tables are in third normal form. If you ignore the little problem that it has there with I could break that down. I could break that compound key out of invoice line items easily. Let's see if there's anything else that I can. Let's see. compound key here. The invoice archive, the key is the invoice ID. Vendor contact updates, vendor ID is the primary key. Those look okay. The only one that's bothering me here is the invoice line items with the invoice ID and the invoice sequence. And the thing of it is, if that were being used to give me a many-to-many relationship here, then I couldn't break it out. But notice that it's based on the account number. So the account number to the account number and invoice ID to the invoice ID. So the invoice sequence number really isn't a part of any external relationship. Therefore, I would cause that to be an identity and to take me through the questions. 3 entities we will track: vendors, invoices, invoice line items. And here they're going through, identify the tables and assigning the columns. It would be at this point that I would, as you read through this, notice that they have struck out a few. The vendor fax number, that they're not going to put that in the database. It could be in the database. But they've taken some stuff out. Item, part number, for example. Okay. After we've identified the entities, we must decide which data items go with which tables. Our authors chose some stuff. You may agree with some of the things they did. I pointed out one thing I disagreed with. Now, let me point out one. I put it here in red. I strongly disagree with their decision that I put in red. I'll point out one mistake. Maybe they just did this to see if some sharp person like me would catch it. Invoice total should not be included as a field. Why? Because it is derived. And I believe I have one in there. I think I put one in there that is wrong. It is inconsistent. It is derived from the sum of the invoice line item amounts. Okay, let's see what that means. I have an invoice line item amount, and I have an invoice total. That means I put the invoice total in there. The invoice total had better match. If I add up all of the invoice line item amounts where the invoice ID equals this invoice ID, they'd better match. What if they don't? Do you see I have a redundancy of information in this database? That is just jumping out at me and grabbing me by the throat and saying, wait a minute, something's wrong here with this design. Do you agree? Argue with me. Never argue with your teacher, right? Well, you definitely can in this class, but in database, I'm probably right. Well, if I'm not usually right, I shouldn't be the teacher. But look at that. Look at the problems I could have here. I have invoice total. Let's see if I have. Let's see. I bet there's something in here. Seems like I put one in there. I want to know, do I have any bad data? Select. Invoice ID. Let's see, how am I going to do this? Invoice ID, invoice total. I'll get this and I'll put it up there. I want to find, do I have any out there where the invoice total at the invoices table is different from the sum of the invoices in the invoice line items. So there's really only two. Well, no, it could be different. Basically, I'm going to add up these numbers right here, 580, 570, 570, and 540. And what? It's the next column. Thank you very much. Thank you for noticing that. The line item amount. So if I add up all of those line item amounts, they better be the same as the one in the invoices table. But why have it there? The only thing I can do is be wrong. If I can get it from two different places, don't have it in two different places. I probably need to know by invoice, so I'm not going to, I'm going to follow that foreign key and add them up. Every time I want to see an invoice line item amount, I'm going to go add them up. Would it be a little less work for the database? Yeah. But that's okay. I've got a lazy database. My database is so underworked. You know, let it do some work. If it keeps you from having a value, do you see my complaint here? Basically, I have a database integrity problem or a place where it can get out. Now, in the next class, we're going to do some programming, and we'll probably program this to where somebody tells you, well, it has to be that way. We're going to write a check that says, go check and make sure that what they're putting in there balances. And we can't do it in a table constraint. We got to do that with a program. So I go look at the other table, add them up, make sure before we, and then I could write a program that just didn't let you get out of sync. Anyway, enough of that. Would be possible to have the value that was inconsistent with the sum of line items. Mistakes, typographical errors, not for me, they don't, but yes, they do happen. You may remember that one of our here it is, outer join queries searched for any row of the invoices that had no children in the, and we found that invoice ID 46 was childless. It has no invoice line items. Did you also happen to notice that there was an invoice total of $224? That's not possible. But there it is. Line 46 has no invoice line items. But yet it has a value in that field. That's an inconsistency. We have an accounting problem. We'll solve that issue in a later class. Generally speaking, I'm agreeing with the author, except for those. Identify the relationships. Notice that the invoice line items are related to the vendors. Here we have straight one to many. You'll see many's done that way a lot. Looks like a little crow's foot on it. And if I don't have a cute picture of a key, I'll make one that looks like that. little crow's foot. Relationships between the what? Vendors, invoices, invoice line items. What am I saying here? Invoice line items showing that here's where I'm mentioning this thing. I'm talking about there's no reason to have a two-field primary key on the invoice line items table. That'd be the first thing there's nothing that's hurting me about that. The database is consistent. The thing that's going to hurt me is that invoice total. Yeah, invoice total appears in two places, and if they get out of whack, I got a problem. So this 1, 1, 2. So here I'm showing some possibles where we have some duplicates. But what if we if our invoice sequence number were 1, 2, 3, 4, 5, 6, 7, and just that is our primary key? I can show you. I'd have 3, 1, 3, 3, 3, 6, and 3, 7 are all on the same. I don't have to have them all together. I'm pointing out some. Many-to-many relationship, be able to identify a many-to-many relationship out of this, a one-to-many relationship, when you use one, when you use the other. What is a many-to-many relationship? It's just two one-to-many relationships put together. Okay, that's all there is. One-to-one relationships, they're all in the same table. One-to-many, they're related through a foreign key, and many-to-many, related through a bridge table. Or sometimes called a linking table, if you prefer. Anytime you see two crow's foot lines or two key lines leaving a table, the many side of it, you have a many-to-many relationship. Maybe that's not the only. We can have two tables with a one-to-one relationship. This is a good example. I have an employee ID, a first name, last name, probably has a department, probably has a phone number, probably has office number, and a lot of stuff about him. And also there is a photograph. I only have one. An employee only has one photograph. I'm not keeping a scrapbook here. I just want to have your picture. A lot of the employees might say, no, I don't want my picture out there. But if you do have a picture, you only have one. This is a good example. In this case, the primary key of the employee photos table is the foreign key into the employees table. Okay. Thus, I have a one-to-one relationship. Thus, if an employee does not want their photograph, and I believe you have a right not to have your photograph on your employer's website, particularly if you ever plan to go into law enforcement or anything like that. They take a dim view of employers are looking up your internet history or what you're saying out there. And it's probably easier to do now than you think. I mean, so I don't know. They're talking about wanting to make that tougher, but employers are going out and finding it. Particularly if your employer is in that security business. I heard a story about somebody who was denied entrance into the armed forces because they did a background check and found some stuff that probably wouldn't want everybody to know about it. I don't know what it was, but that's what I heard. First normal form. Column that contains repeating values. If I have repeating values, then I want to pull those out to another table. So for example, I have vendor name, invoice number. So here I have stuff that is really about two different entities. So that that vendor name, I don't want to repeat it all the time. So that gives me the idea of I'm going to break it into vendors and an invoices table. Because vendors and invoices, if I'm gonna have all of that stuff about vendor name and then vendor address, I'm gonna have it repeating and repeating and repeating and repeating. Anytime I have that, it needs to be broken out. And the invoices table. Data with repeating columns. You will hit this. Vendor name, invoice number, and items. So this is the one where I have repeating data here. I break it out into the vendors and the invoices, but notice that now I have repeating columns. That's the idea of the invoice line items. It is broken out to avoid this idea. Notice that item description 3, I have nulls in there. How many items can I have? I don't know how many items you can have. I guess 1 million. Well, do I have 1 million fields in this table and 99,000 of them are always null? It doesn't do any good. Many textbooks would say this is in first normal. No repeating. So here it is in first normal form. Do all the fields contain single values? If we didn't want to break this out into words, it does. And all rows different by design of the database. All rows have to be, all rows are different. Yes. We add keys, and then they're going to get broken into keys. And now we have broken out the invoice sequence into this one. I have to have the invoice ID. I would have made the invoice sequence number the primary key instead of together. Next. Third normal form is when we're in the second normal form. I have two things here. I have invoice ID, invoice information, and vendor information. So I have two entities in the same table. I have vendor and I have an invoice. I need to break those out. And this process is more of an art form than it is a. And finally, here is our accounts payable in third normal form as we have it on our data. Finish after sailing. Let me see, I think we're just about, okay, so here we have the key, the whole key, and nothing but the key. So help me, COD. COD being the person who developed this. Find in the invoices table, find a field in the invoices table that depends on something other than the invoice ID. And the invoice total field is our problem. It's not a property of the invoice ID. That needs to come out of there, in my opinion. Invoice total should be removed. It should not be a part of, because it's not a property. Yes, it's a property of the invoice. It can be shown there. It makes sense to show it on the invoice. It makes sense to think of it as part of the invoice. It is a property, but it is derived from adding up the invoice line items. So in the next class, we're going to make that happen. So I would get rid of the invoice total. Thus we have the key, first normal form, the whole key, second normal form, third normal form. Here's a quiz. The reading is important in the textbook. It's more than just listening to me talk. This particular idea goes to every database that you're going to pick up. Is you're going to have it, it's going to be set up just in this fashion. So they'll be set up in tables of foreign key, primary key relationships. Usually the table joins are on a foreign key primary key. To get a one-to-many relationship, a many-to-many relationship involves foreign keys and primary keys. And that's what this class is essentially about. And then the breaking it up into the various tables, there are other ways it could have been broken up. There are other things that this author could have done, but chose not to. By and large, I agree with him. Here's one that I will frequently give as a problem in a database. Okay, you are designing a database. Let me leave you with this one for thought, and then we're going to take a break and go to lab, and I got some other stuff we need to do tonight. But you're designing a database, let's say for Collin College. And Collin College has asked you to write a database that helped them track incidents. So somebody reports an incident, and they want to keep track of incidents, who reported them. So you already have a primary key there, college-wide ID, but assume that you have that, or their name. Then you have referral sources. So an incident can be referred to, it could be referred to the dean if it's a student matter. It could be referred to security. It could be referred to Frisco Police Department. Could be referred to facilities. So there's, maybe there's an incident, something's wet spilled on the floor. Okay, that's referred to the facilities people, go mop it up. Or it could not be referred. So how would you keep track of these in a database? That's a real world problem. And we were once asked to do that for Collin College. Got a bunch of different solutions on it. One I really liked. A couple I really liked. Okay, let's see. Anybody out there in... Okay, let me... Renee, I'm going to unmute you. Oh, I guess you're muted. Renee, if you want to turn your mic on, if you have any questions, you may ask. If not, I'm going to enable test 2 at this time. And this means that you will have all weekend and Monday. I will assess a penalty if it goes beyond the due date on that test, because I'm giving you plenty of time. You'll see the due date on it. It's going to... 2 hours. Turning it within 2 hours. I have I'm going to say, I'll say a little bit longer, but I'll see when you access the test. So you can go to the test, you can read the instructions without accessing the test, and then it says, you'll begin the test when you do this. The test, I think it's going to take about 2 hours. I might open that up a little bit. Okay. Let's say I open it up to 3 hours. Okay. Now, so that means you can choose when you start. Once you start, you have that time limit on it. I'm not going to hold you to the penny. So I'm kind of looking about there. So if it takes you, 2 days, that's a problem. Don't go beyond when the due date on the test is 11:59 on Monday evening. I'm not going to set it to shut off and lock you out, because I'll have people, the violins start playing. But it will cost you if you are late, if you are after 11:59 on Monday. No, not me. Okay. So I'm going to enable the test here in just a minute. And so we're going to take a break. I'm going to turn off the recording now. I'm going to leave the stopping recording now.